Mr. Sand, and now we're going to go through 2D Force Addition. Now, 2D Force Addition is just like the other two-dimensional kinds of vector addition that we've been doing before. And the basic strategy to do this is to figure out the x components of all your vectors, your y components of all your vectors. You sum all of those x components together, you sum all the y components together, and then you find the resultant from your x and your y vectors. So I'm going to go through both of the warm-up problems, and I'm going to let you go through the practice problems on your own. And if you have any questions, let me know. So let's just go through this. I think the best way to do this is just through practice. It's a method of decomposing the vectors into x and y coordinates and then adding them together to find the final overall x vector and the final overall y vector and finding the resultant. So here we go. Let's do it. It says, number 1, Hector is walking his dog Fido around the neighborhood. At the corner, Fido refuses to continue on the walk. This happens all the time, by the way, like with little tiny dogs. I don't know, living in New York, I see it all the time because it seems like I don't know why it is, but these dogs just are very resistant in New York and they don't like to cross the street. So they just stay at a corner and refuse. So let's just imagine that happens here. Well, Hector yanks on the chain with a 67 Newton force. Yow! That would hurt. At an angle of 30 degrees above the horizontal. Determine the horizontal and vertical components of the tension force. So let's just suppose that Hector is pulling at an angle. Well, let's get this right here. Let's get... All right. So let's say that here's the dog. Here's the dog. The stick dog. There it is. And there's a chain. Let's make the chain a brown color. Here's the leash. And say it's like this. And it's got this angle right here that's 30 degrees above the horizontal, which is right there. Okay, so he's pulling. And what's the force? The force says 67 newtons. 67.0 newtons. All right, so what's the horizontal and vertical components of this tension force? So this is the tension force right here in the chain. It's going this way. The tension force is right here. This is Ft. Should be a T. Oh, that's a T. Trust me. So we want to decompose this into X and Y. I'm going to do X as red and Y as blue. Here's the X component. And here's the Y component. If you add these two vectors together, they will get this hypotenuse here. These will be at a 90-degree angle from each other, obviously. So let's look at the X component first. The X component. So put this in X. Make this very clear. X, well, to find X from this angle right here, call that theta. Theta. This is the adjacent. And this is the opposite side. And this, of course, is the hypotenuse. So, what can we say about this X side right here? Well, we could say that the sine of 30 will equal, 30 degrees, will equal, since we know from SOHCAHTOA, it's going to be, oh, I'm sorry, not the sine, my bad. It's going to be cosine. Cosine of 30. It's cosine of 30, and it's going to be, we'll call this x over the hypotenuse. The hypotenuse is 67.0. So to find x, all you do is you take 67.0 times cosine of 30. When you do this, you're going to get 58.0 newtons. That's the X component of the tension force. That's part of your answer. Now let's do blue for the Y component. And you can probably guess what I'm going to do here. So the sine of 30 degrees is Y over the 67.0 newtons. So multiply both sides by 67.0, you're going to get 67.0 times 30 sine, and this will get you your y, which is 33.5 newtons. This is your y component. So this right here is 33.5 newtons, and this over here is 58.0 newtons. That's that component. So the blue arrow is this, and the red arrow is this. Great. That should be easy. It's just building up to number 2. Number 2 says, Landon pushes a car with a force of 22.3 newtons exactly east. Violet is pushing the car with 34.1 newtons at 11.2 degrees north from east. What is the magnitude of the force on the car, and in what angle from east? Right. So first of all, let's just draw this scenario. I'm going to get a brand new sheet here. Okay, here we've got a car. Let's put the car in black. Here's the top of the car. Looks like the old Grand Theft Auto kind of car. Old. You just got the top view in that game. Okay, so here's a car. Landon is pushing with his force. I'll put his force as pink. His force is this way, I think. Yeah, his is exactly east. So I'm sorry, I needed to back up a little bit. North, south, east, and west look like this on a compass. So we always consider this way to be east. That's north, that's west, that's south. They're all 90 degrees from each other. So east is this way, and his magnitude of his force is 22.3. So all I'm doing is drawing this out here. And now we've got violet. Oh, we've got to draw violet in violet. Where? Oh, that's kind of violet. There we go. Violet's pushing at a slight angle. It's a very small angle like that. Okay. Her angle is 11.2. Yeah. 11.2 degrees north of east. So it's north of east. It's north of east. And her magnitude, she's pushing harder. It's 34.1 newtons. Great. So we want to know what is the magnitude of the force of the car and what angle from the east. So we're adding these two vectors together. That's all this is just adding these vectors. So you've done this before. Since Unit 2, you've done this. So let's just do this again. So obviously, in the x direction here, let's do the x first and then we'll do the y. The x direction here, we've got Landon's totally in the x direction, and he's not doing anything in the y direction. So he's pushing everything in the x direction. So in the x direction here, make a little chart for the x direction. We've got Landon's force, which is 22.3 newtons. There's nothing in the y from, I'm not in the y yet. There's nothing from the y from Landon. All right. So this is entirely in the x direction here. But what about violet? Well, violet in the x direction here, just like the problem before, we can kind of go a little bit faster here. We can say for violet, her force in the x direction is going to be 34.1 times the cosine of 11.2 degrees. Okay. Now, if you add, so 34.1, yeah. I want to make sure I get this right. I don't have this written down. 34.1 times the cosine of 11.2 is 33.4. So that's 33.45, blah, blah, blah. Okay. You add these two numbers together, and you're going to get a total sum in the x direction of, let's see, 55.75. 0.5, whatever, 7, blah, blah, blah. Okay, that's the force in the x direction. Now, what about the y direction? Let's do it really quickly. We can do it in the y direction. Here we go. In the y direction, there's nothing from Landon, so I just put nothing there. Now let's talk about violet. Well, for violet, it's going to be 34.1 times the sine of 11.2. What is that? 34.1 sine 11.2. This turns out to be 6.62339, blah, blah, blah. Okay. So this is our y component, and here's our x component. So if I draw this out, the y component's not going to be as big as the x component, obviously. So here's, let's just say this is 6.62. Let's leave it as 3 sig figs for now. And this is much bigger in the x direction. It's going in this direction, like this. This is going to be 55.8 newtons there. So we want to know what the resultant is. The problem isn't over yet. We want to find the resultant. So the resultant is these two vectors added together. It's going to look something like, whoa, hello, like that, except that's supposed to be a straight line. So to figure out what this is, you do the Pythagorean theorem. Yeah, it's going to be 55.8 squared plus 6.62 squared, and that will equal this squared. So I'll just call that c squared. So the magnitude of this is going to be the square root of 55.8 squared plus 60.62 squared. That will equal our height. That'll equal our resultant. Okay. So I'm going to do that really quickly. We should get as a result 56.1 newtons. All right, 56.1 newtons. And what angle? Well, to find the angle, that's pretty easy. Here it is. You do the inverse tangent, or the arctan. You say the inverse tangent. I hope you remember how to do this. The inverse tangent of 6.6. Oops. 6.62 divided by 5. 5.8. 5.8. And you're going to get 6.77 degrees north of east. Okay, I went quickly through this so I could fit it all in one video. I hope that makes sense. I will talk to you about questions if you have them. Okay, bye-bye.